गुड मॉर्निंग। ये हमारी एमएससी प्रीवियस ऑर्गेनिक केमिस्ट्री की क्लास है। रिएक्शन मैकेनिज्म पोर्शन में हम पढ़ रहे हैं रिएक्शन इंटरमीडिएट्स। रिएक्शन इंटरमीडिएट्स में अब तक हमने फिनिश किया है काम। वी हैव स्टडीड इन डिटेल्ड कार्बोकैटायन, कार्बोनाइन, फ्री रेडिकल्स and then carbons. And today we are starting another important reaction intermediate, that is nitrenes. So in fact, nitrenes are nitrogen analog of, I will say in simple definition, nitrogen analog of carbon. Simple. Carbon आपने पढ़ लिया तो बस nitrogen analog of carbon you can say, and that is nitrenes are like this. Now, as in carbons, nitrene can also be singlet as well as triplet. So I am representing here both the types of carbons. Say, if both the electrons are paired, then it is going to be a singlet nitrene. And if one of the electron pair is paired and two electrons are unpaired, then it is going to be triplet nitrene. Now, in both the cases, you can see it is a count 2 to 4 and 2 6, 2 to 4 and 2 6, that is, it is a 6 electron system and neutral, but strong electrophile in nature. Strong electrophile because 6 electron system and they are short of 2 electrons, and hence they are strong electrophile in nature. And carbons are also like, but electrophilicity of carbon is less than the nitrene. Okay, formal charge is 0. इनके ऊपर फॉर्मल चार्ज आपको काउंट करना आता ही है. फॉर्मल चार्ज इज 0 ऑन देम. नाउ लेट अस स्टडी अबाउट द स्ट्रक्चर्स. कोई प्रॉब्लम नहीं होगी स्ट्रक्चर में. कार्बन से हम पढ़ चुके हैं तो कार्बन के बाद नाइट्रीन में पढ़ने में कोई दिक्कत नहीं आती. सबसे पहले हम लेते हैं से सिंगलेट कार्बन. नाउ सिंगलेट कार्बन इज दिस आर एन एन एन. नाउ इन सिंगलेट कार्बन this nitrogen is sp2 hybridized. This nitrogen is sp2 hybridized. Now nitrogen sp2 hybridized का मतलब क्या हो जाएगा? देखो, there will be 3 hybrid orbitals. Nitrogen will be having 3 hybrid orbitals. Then these 3 hybrid orbitals will be like this. One of the hybrid orbital, another hybrid orbital of nitrogen, another hybrid orbital of nitrogen at an angle of this, and one unhybrid perpendicular p orbital. They are in one plane and this is perpendicular to all these. Now this p orbital is vacant. This perpendicular p orbital is vacant. This is forming one of the bond with hydrogen atom or any other alkyl group. It is having one electron and it will form bond with any other atom. See, it is forming a bond with H. One of the hybrid orbital is forming a bond. Now other 2 hybrid orbitals which are lying at an angle of 120 degree have 2 paired electrons. They have 2 paired electrons in this. And hence the singlet nitrogen is in excited state. Nitrogen is in excited state. Okay. Now when we come to the structure of triplet carbon, so triplet carbon is this. Now in this case triplet carbon, this nitrogen is sp hybridized. Now you know sp hybridized means there will be 2 hybrid orbitals at an angle of 180 degree, and there will be 2 hybrid orbitals, 2 perpendicular p orbitals which are perpendicular to themselves and perpendicular to this hybrid orbital. So they can be represented like this. They are perpendicular to this and perpendicular to each other as well. That is, this angle is 90 degree in this. They are pure p orbital and they are the hybrid orbital. Now what is this? Now one of the hybrid orbital is forming a bond, like see, it is forming a bond with H. Another hybrid orbital is having a paired electron. Now these two p orbitals which are perpendicular to each other have one electron each. They have one electron each, and hence in this case this triplet nitrene, nitrogen is in ground state. Nitrogen is in ground state. Therefore you can say, as if we compare the stability as was explained to you in the carbon, triplet is more stable than singlet nitrene. Therefore in 99% cases triplet nitrene is formed. Triplet nitrene is formed because the reason for this will be that singlet nitrene is thermodynamically unfavorable and half-life period is very less. You can say that most of the nitrines formed are this triplet carbene. Singlet nitrines are not formed because their stability is very, very less. Okay, this was about the introductory part of nitrene, definition of nitrene, their structure and unstructured. After studying carbene, you must be knowing that it is quite similar to the structure of carbenes. Okay, now come to how they are forms. Generation of nitrene. Generation of nitrene. How nitrines are formed. Okay, nitrines are formed basically by photolysis and thermolysis method, that is pyrolysis method. Sometimes it is formed by alpha elimination of base, if we are using base as catalyst. Then this is the most common method of formation of this is from photolysis. Say for example acid azides or acyl azide. Let us take the example of photolysis acyl azide. Okay, acyl azide, you know, acyl group is this R C double bond O N. Now you should know the structure of this azide group. 2, 3 and 1 electron pair on this. 2 and 2, 4. No electron, so it will be having a positive charge. 2 to 4 and 2, 6. It will be having a negative charge. In general, we can represent it like this: RCON3. Acyl azide they are called. Now what happens when they are subjected to light or heat? Thermolysis or photolysis, both one the way. So what will happen is, see, electron. This electron pair shifts to this position and this electron pair is taken by this nitrogen and this electron pair comes here. So it will form N triple bond and nitrogen, and this will form an acyl nitrene. Acyl nitrene is formed, that is RC double bond O N plus N triple bond N. Now similarly you can say if we have acid azide, normally we call them acid azides. हम acid azide बोलते हैं, RN3 लिख दें. Alkyl azides, we can say alkyl azides. And so next example, acyl azide. So कोई difference नहीं होगा, केवल मैं उसके अंदर this CO group में लिखेंगे. If it is a acid azide, normally they are called like this, R double bond N. This will be having 2, this will be having a 1 electron pair, no charge, positive charge on this, it will be having a negative charge. In a similar fashion, it will form a nitrene. This electron pair comes over here, and this electron pair is taken by this positively charged, and this electron pair comes over here, and after this heating or this, it will form Rn plus another product will be nitrogen in this case. Okay, this is the very common method of formation of, it is formed by heating or by light of acid azides or acyl azides. This is called acid azide, Rn3. Rn3 in general, what we call them is acid azide, and this they are called acyl azides. Many reactions comes across our study that how they are formed. Secondly, another method of the formation of this is by base catalyzed reaction. Base catalyzed elimination, you can say. Base catalyzed elimination, say. See, we have halogen substituted amines, say R, N, X, and here we have H. Okay. Now, in presence of base, what will happen? If we are treating it with a base will abstract proton. This base will abstract the proton like this. Base proton ले लेगा हमारे पास ऐसे, and this electron pair will come to this, and simultaneously halide ion departs. Now what is the result? R N plus halide ion plus BH. Similarly, we can have amides. R C double bond O N Br, or here it is H, amide. In the similar fashion, what will happen in this case? In presence of base, what will happen here? Now, in presence of base, what will happen is base will abstract this proton. This electron pair moves to this, and halide ion departs. The product formed will be acyl nitrene plus bromide ion and BH. BH and this halide ion departs in this case. So this is how nitrines are generated. ये हो गया how nitrines are formed, what is nitrene, nitrines क्या होते हैं, कैसे बनते हैं, स्ट्रक्चर क्या होती है, ये सारी चीज़ें हमने नाइट्रीन्स के बारे में देखी. नेक्स्ट हम देखते हैं कि नाइट्रीन्स की रिएक्शंस कौन सी होती है. ओके, नाइट्रीन्स की रिएक्शन में देखो बहुत सारी रिएक्शंस आप पढ़ते हैं, उस समय हम पता नहीं चल रहा दे आर कंप्लीटेड थ्रू फॉर्मेशन ऑफ इंटरमीडिएट नाइट्रीन. सी we will take the examples like Hoffman rearrangement, and say Curtius rearrangement, Lawson rearrangement. All these reactions are completed through formation of nitrines. Not only these reactions, they also give reactions, insertion reaction. As in carbons they were giving, they also gives us insertion reaction. So, and important thing about the reactions of carbon is that alkyl nitrines always undergo instant rearrangement. They will readily undergo instant rearrangement, and they also give insertion reaction. They can also be inserted in multiple bonds to form cyclic compounds, aziridines, and like that. ये सारी रिएक्शंस हम पढ़ेंगे अपने नेक्स्ट लेक्चर के नाइट्रीन्स में. नाइट्रीन्स एक बहुत ही इम्पॉर्टेंट इंटरमीडिएट है. जब नाइट्रीन से रिलेटेड क्वेश्चन आता है नेट टाइप एग्जाम में, थोड़ा डिफिकल्ट लगता है हमें, लेकिन इसके हम सारे एग्जांपल जब कर लेंगे, लाइक हॉफमैन्स रीअरेंजमेंट, लाइक कर्टियस रिएक्शन, लाइक दिस लॉसन रीअरेंजमेंट, then you will come to know how important intermediate this nitrines is. Okay, keep doing your work. Thank you very much.